Hey guys, this is the study guide for exam 2. That means that all of the questions on exam 2, a version of them will show up in this review. So if you can do this review, you should feel ready for the exam. I started the video and then I restarted it. So I'm just going to write on this one for number 1. Number 1 says determine which of the given points are on the graph of the equation. The equation is y equals x to the fourth minus the square root of x, and the points that they give us are the point 1, -1, 0, 0, and -1, -2. What does a point mean? A point means that that is an x and a y value that if we look at the coordinate plane and we start at the origin 0, 0, example for the point 1, -1, that means we'd go 1 to the right for x and then 1 down for y, and that point would be right there. So it's just directions how to get there on the coordinate plane, and also what the value of x is and what the value of y is if we're going to just mathematically put it into the equation. So you are welcome to graph that in Desmos or in a graphing calculator. Let me share my screen. So one option specifically if you're doing homework would be y equals x to the power of 4 minus, and then you need the square root button. So if you don't have it on your keyboard, you can just pull up that guy, and then that'll give you the graph. And then it will give you some points on the graph, but it will not easily give you all of them. So that might help you. But a reliable way to do it is to just do it mathematically. So we have the point 1, -1, and we have the equation y equals x to the fourth minus the square root of x. We know that the point 1, -1, x is equal to 1, and y is equal to -1, right? So we have y equals x to the fourth minus the square root of x, where, for the first one, y equals -1, x equals 1, right? So I'm just going to put those in. -1 equals, my x is 1, 1 to the power of 4 minus the square root of 1. I always use parentheses just to reduce the probability that I make a mistake. So -1 equals 1 to the fourth is just 1, and then the square root of 1, you can put it into your calculator if you want. You can put it into the Desmos calculator if you want, but the square root of 1 is just 1. So it's 1 minus 1, right? The square root of 1 is 1. 1 to the fourth is 1. So -1 equals 1 minus 1 is 0. So I'm going to say that that is not a point that is on the graph of the equation. If you went back and looked at the graph that you have on Desmos, you would see down here, you can put in 1, -1. And you can see that it is not on that line of the equation. Good. We'll go to the next point, which is 0, 0, right? That means x is equal to 0 and y is equal to 0. So same equation, y equals x to the fourth minus the square root of x when y is 0 and x is 0. So we have 0 equals 0 to the power of 4 minus the square root of 0. 0 to the fourth is still just 0, and then the square root of 0 is also 0. So 0 minus 0, 0 equals 0. So that one is true. So I'd say this one is an equation, is a point that's on the graph of the equation. Good. We'll try that last one now. -1, -2. Y equals x to the power of 4 minus the square root of x when y equals -2, x equals -1. Remember, x is always the first one, y is always the second one. So we have -2 equals -1 to the fourth minus the square root of -1. Negative 2 equals negative 1 to the fourth is just negative 1 four times if I use the parentheses. It's just a positive 1. The square root of negative 1 is not a real number, right? So we could say it's I, right? Or we could say it's just not a real number. Either way, that's not going to equal negative 2. So it's not this point and it's not this point. It's only that middle point. And notice, I'm going to go back to my other paper. Same equation though. I just had to print it again. So we decided that that is not possible. We decided that that one is possible. And then I kept going because it says which of these select all that apply. So you don't want to stop when you find one. You want to make sure you can also rule out that second one. And it is possible that none of the points are on the graph. In that case, I would recommend if you go through the three of them algebraically, so you go through the three of them by solving it, and none of them are on the graph, I would then graph it and then graph the 3 points to make sure that that is true. So if I go back to Desmos, 1, negative 1, we said was not on the line, and then we have 0, 0, and you can ask Desmos to label it for you. And then we have the point negative 1, negative 2, and you can see that it looks like 0, 0 is on the line. It's 1, negative 1 is definitely not on the line, and negative 1, negative 2 is definitely not on the line of the equation. Shouldn't call it a line. I should call it a graph because it's not a straight line. The graph of the equation. Number 2 says determine whether the given points are on the graph of the equation. Same question. Good. So you're welcome to graph this in Desmos and graph those points, see which of them touch, or you can do it algebraically, which is y squared equals x squared plus 25 when y equals 0 and x equal, nope. That's another thing that is a risk. That is an error. High risk error, I would call it. So y is in fact 5 and x is the 0. So we say 5 squared equals 0 squared plus 25. 5 squared is 25. 0 squared is 0. So it is true that 25 equals 25, right? Sorry about that. So that one is true. Go to the next one. The next one is 5, 0. Y squared equals x squared plus 25 when x equals 5 and y equals 0. I'm going to start writing them in XY format so I don't mess up again. Let's see if that's true. So y is 0. 0 squared equals 5 squared plus 25. 0 equals 25 plus 25. We know that that is not true, right? So I can say no to that one, and then we'll just plug in that third one and see what happens. Negative 5 and 0. Same equation, y squared equals x squared plus 25 when x equals negative 5 and y equals 0. So 0 squared equals negative 5 squared plus 25. 0 equals negative 5 squared is positive 25 plus 25. So this is why it's important. So that's not true. This is why it's important to use the parentheses because had I just said negative 5 squared plus 25, I would get 0. But I need to put it in parentheses because I'm substituting the whole x for negative 5, right? The whole x is being squared and the whole x is negative 5. So that's 50. So they might try to trick you on that. So that's also a no. So I'm going to say the only point that is on the graph of this equation is 0, 5. Find the slope of the line and interpret the slope. For this question, we need to use the slope formula, right? The slope formula is what we use when we have 2 points and we need to find the slope. You're welcome to just count also, because slope is always rise over run. We call slope m. So m equals the change in y over the change in x. Okay, so if you're starting from 0, 0, how much are you changing in y to get to 5, 3? You're going up 3. And then for x, how far are you going over to get from 0, 0 to 5, 3? 1, 2, 3, 4, 5. And in a positive direction, right? So you can just say that the slope is positive 3 over positive 5, which is 3/5. Good? Okay. Or if it's not easy to count, or if you just want to make sure, the equation to find the slope of a line is m equals the change in y over the change in x. So that means the y value of your second point minus the y value of your first point divided by the x value of your second point minus the x value of your first point. It does not matter which one you make your first point and your second point, okay? I'm just going to say that this is x1 and this is y1. And I'm going to say this is x2 and y2. Okay, so I'm just going to plug those in. x1 is 0, y1 is 0, x2 is 5, and y2 is 3. Good. So now I just look over here. Y2 is 3. Keep that minus. Make sure you carry that minus over. 3 minus 0 for my y1 divided by 5 minus another 0. So that's 3 over 5, which is the same thing we got when we were just counting. If you had made this point your x2 and y2 and this point your x1 and y1, I just want to go over that really quick, then that would be 0 minus 3 divided by 0 minus 5. And you're thinking like, isn't this going to be different because they're negative? It's going to be a negative slope. Negative 3 divided by negative 5. A negative divided by a negative is a positive, so it's just going to be 3/5. 3 divided by 5 or negative 3 divided by negative 5. They're both a positive 0.6 or a positive 3/5. The slope of the line is 3 over 5. Simplify your answer. A good way to simplify your answer is to go into Desmos. The scientific calculator, if I had, 5/15, for example, as my fraction, your answer shows up on this side, press the convert to fraction button, and you'll see it in its simplest form. Okay, so we can just make sure that 3/5 is in its simplest form by clicking on the fraction button, and it will show us that it is. Okay, now interpret the slope for every 5-unit change in x. Every time you move 5 on x, how far do you move on y? You move 3. Make sure that the signs match, okay? If that 5 is a positive, the 3 should be a positive. For every negative 5-unit change in x, the change in y is negative 3, okay? So imagine it as a fraction. 5, 3 over 5. If they had tried to trick us and said for a negative change, make sure you don't say it's a positive 3, right? It would be a negative 3. I don't think that will happen, but. All right, same question. So again, you're welcome to just count. Remember that slope is change in y on the top of the fraction over change in x. So from this point to this point, how far did we move on the y-axis? We went from 1 to -1, so that's a -2, okay? Because I'm starting from here and I'm going down 2. Sorry, I'm gonna have to pause for a lot of coughing fits. So we went to get from this point to this point, we went down 2 on the y, -2y. And then, how far did we move on the x to get from -1 to 4? That's 5, right? 1, 2, 3, 4, 5. Now we see that 1 is the y we moved in a negative direction, but the x we moved in a positive direction. A negative divided by a positive is always a negative, so the slope is -2/5. Good. You can also use the slope formula. M equals y2 minus y1 divided by x2 minus x1. I'm going to call this my point 1. So x1 is -1, y1 is 1, just from copying those points down. This will be point 2. So my x2 will be 4, and my y2 will be -1. Now I just plug these in over here. Y2 I said is -1. Y1 is 1. Don't forget that minus sign. And then x2 was 4, minus sign. That's a -1. So make sure you include both the minus and that negative sign. So -1 minus -1 is a -2. And then 4 minus -1, you can put it in your calculator. 4 minus -1 is actually a 5 because you're adding two negatives become a positive, right? It's just a big plus sign. So that's still -2/5. Slope of the line is -2/5. I just had to pause to cough, and then I was looking at my how I'm almost at the end here, and I tried to use my mouse to scroll down on the page, even though it's just recording. It's a picture, and I can't scroll on the picture. I had to move it in real life. All right, so here's what I mean by interpreting the slope. For every 5-unit change in x, for every 5-unit change in x, and make sure you think about which one is the y and which one is the x, right? So for every 5-unit change in x, the change in y is a -2 change. Okay? For every -5-unit change in the x, the change in y would be a +2. So if you have a -1, make sure that one is negative and one is positive. One is negative and one is positive. If it's a positive slope, make sure that they are both positive or they're both negative. So that's number 4. Find the intercept and graph the equation by plotting points for, oops, sorry, can't even see it. Find the intercepts and graph the equation by plotting points for 3x plus 2y equals 6. What are the intercepts? Select the correct answer below and fill in the answer box to complete your choice. Okay, so we have 3x plus 2y equals 6. How? You could use any point, right? But we don't really want to spend more time than we need to. So we're going to start with the x-intercept and the y-intercept. So to find the x-intercept, we want to set y equal to 0. Good? Okay, so in this equation, we're just going to leave x as x, and we're going to make y 0. 3x plus 2 times 0 equals 6, and we're just going to solve it for x. 3x plus 2 times 0 is 0 equals 6. That just disappears, right? So we just have 3x equals 6. How do I get x alone? It's being multiplied by 3, so I'm going to divide it by 3. X equals 2. So what we have now is x equals 2 when y equals 1. So the intercepts are 2, 0, because remember, it's always x followed by y. And to find the y-intercept, to find the other intercept if there is one, set x equal to 0. Good. So now we have 3 times 0 plus 2y equals 6. 3 times 0 is just 0 plus 2y equals 6. 2y equals 6. How do we get y alone? Divided by 2. And we get y equals 3. Y equals 3 when x equals 0. Now, remember, it's always x first and then y. So it's 0, 3 would be the other intercept. It asks you to graph the equation by plotting points. You have the 2 points. Your points are 2, 0. Gosh, this is infuriating. I'm too old, too blind for this. So go 2 to the right. Don't go up or down, right? Because it's y equals 0. And then for this one, x equals 0 and y equals 3. So we're going to go up 3. And then you would just find your ruler. Well, you wouldn't because this is an online test, right? But those are the points you would use to graph that line. You'd use the graphing tool. Here, so that was find the intercept. Here they're asking you to find the slope and y-intercept of the line. You can just move it into slope-intercept form if you want. And remember that slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. Good. So currently we have it in 4x minus 3y equals 12. xy equals a number without a variable. So that would be standard form. So we're just going to move it over into slope-intercept form. 4x minus 3y equals 12. I want to solve it for y. Here, y is being multiplied by negative 3 and 4x is being added to it. To undo this, I'm going to start with a 4x. 4x is being added because it's a positive 4x. So I'm going to subtract it. Anything I do to this side, I have to do to the other side. It's not going to be 12 minus 4 because those are not like terms. Okay, we have a 12 and we have a negative 4x. So now we have negative 3y equals 12 minus 4x. If you want it to be in slope-intercept form right now, you can change the order of these. So you have negative 3y equals negative 4x plus 12, just to make it look more like that. Now y is being multiplied by a negative 3, so I want to undo that. So I'm going to divide it by negative 3. Make sure it's a negative 3. Because we're not doing the opposite of that sign, we're doing the opposite of what is happening to x, the operation, right? The operation is multiplication by negative 3. So the opposite of multiplication by negative 3 is division by negative 3. That cancels. We have y equals negative 4x divided by negative 3. This is how I would write it. Negative 4/3 x. And then we have plus 12 divided by negative 3. Well, if I put the negative 4 divided by, sorry, negative 4 divided by negative 3x plus positive 12 divided by negative 3. Good? Now let's simplify these fractions. Again, you're welcome to just go into Desmos, type in negative 4 divided by negative 3, see what it gives you. Negative 4 divided by negative 3. Oops. Be more careful. That's a little bit confusing. All right, -4 divided by -3 in fraction form is just a positive 4/3 because a negative divided by a negative is a positive. And then if you change it from -4 to our next term, which is 12, we see it's equals -4 because 12 divided by 3 is 4. A positive divided by a negative is a negative. Good? So I think what I wanted to do for that step is to just get the x away from the fraction because we're used to looking at the slope, right? We're used to looking at the slope as a number and then the x. And right here, it's part of the fraction. That looks a little bit confusing. So if anything's ever at the top of a fraction, it means multiplying. We're multiplying -4 times x, right? So you can put it out here because we're still multiplying -4 times x, but then we're dividing it by 3. -4 divided by -3 is 4/3 x, and then we saw that +12 divided by -3 is a -4. So now we have it in slope-intercept form. We know that the m is the slope, and that the b is the y-intercept. So our slope is 4/3, and our y-intercept is -4. The slope is 4/3, and the y-intercept is -4. Graph that. How would you graph that? Y-intercept is going to be along this line at 0, 4, right? 0, -4. And then the slope is 4/3, so we're going to go up 4. 1, 2, 3, 4 over 3. 1, 2, 3. And if you want to just be super sure, you can make sure that that point, and what would that point be? 3, 0. You can make sure that that's also on the graph of the line. So that would mean x is 3, y is 0. Let's plug that in right here and see if it's still true. So 4 times 3, because x is 3, minus 3 times 0, because y is 0, equals 12. 4 times 3 is 12. -3 times 0 is 0. 12 plus 0 equals 12. That's true. You can even do the same for your y-intercept if you want, because you know that the y-intercept is -4. That means the point is 0, -4. So we can take that same equation and say x is 0, y is -4. 4x minus 3y is 12. Is that true? 4 times 0 is 0. -3 times -4 is a positive 12. 0 plus 12 equals 12. That is also true. So you know that those 2 points are definitely on the line of the equation, and they are the y-intercept and the other point when you use the slope that we found. Good? All right, we'll just do one more example of this. Find the slope and y-intercept of the line and then graph the line. Here we have x plus y equals 5. And we want to put it in slope-intercept form. Y equals mx plus b, where that is the slope and that is the y-intercept. So right now we have x plus y equals 5. We're going to subtract x from both sides. And we have y equals -x plus 5, right? Or 5 minus x, but I just changed the order because we want it to look like that. What is our slope? Our slope is this. It's kind of tricky, but that's going to be a -1. Negative x is the same as -1 times x. So these are all the same. These are all different ways to write the same equation. So y equals -1 times x plus 5, y equals -1 x plus 5, y equals -x plus 5. Those are all saying the same thing. But if you're trying to find the slope, you need to be able to recognize that the slope is a -1. Okay? And then our y-intercept is just a positive 5. Good? So the slope is -1, and then the y-intercept is 5, which is the point 0, 5. That's how you would graph it. You'd graph it by going 0 on the x-axis up to 5 on the y-axis. That's your first point. And if your slope is -1, you need to turn that into a fraction, right? -1 divided by 1. It's not going to be -1 divided by -1. It's just and whatever your whole number is divided by 1. -1 divided by 1 is -1. Good? But -1 divided by -1 would be +1. So if your slope is -1, whatever your slope is, and you need it to turn it into a fraction, divide it by 1. Okay? So y, down 1 on y, positive or right on x. And you can go as long as you want. But pick one of those points. That'll be your graph of the equation. Good? Okay. Now it says graph the line containing the point P and having slope M. So the point P is -5, 4, and the slope is 0. They're not asking you for the equation, they're just asking you to be able to, that you are able to graph it. Show you are able to graph this. The point P is -5, 4. Remember, it's always x and then y. So starting from the origin, we're going to move -5 on the x and then up 4 on the y. And put our point right there. Our slope is 0. Remember, I told you back here, if you have a slope that's a whole number and you need to turn it into a fraction so you know how high to go and how far left or right to go, you put it over 1, right? So that's -1 on the y, +1 on the x. We went down 1 over 1, down 1 over 1, down 1 over 1, right? Here we have the number 0, but it'll still work. M equals 0. You can turn that into a fraction. 0 over 1, okay? And remember, that's y over x. So on my y-axis, I'm going to go up or down 0. I'm going to move 0 on y, and then I'm going to move 1 on x. 0 on y, 1 on x. 0 on y, 1 on x. So if your slope is 0, you just have a straight horizontal line. Good? All right. Next, we have the point 7, -3. Our x is 7, our y is -3. So we're going to go over to 7, down to 3, which I should call -3. So that's my point P. And then my slope is undefined. What does undefined mean? Undefined is something that happens when you try to divide a number by 0. So over here, if your slope is 0, that means there's a 0 on the top and 1 on the bottom. Undefined means whatever number you have on top, you divided it by 0. What happens? It says error because you cannot divide by 0. Good? 0 divided by 1, that's fine. That's still 0. 1 divided by 0 is an error. So that's enough information, though, to know what you need to do. You need to go 1 on, remember, I almost made a mistake right then. Remember that the first number is y, the top number is y, the bottom number is x. So you need to go up 1 on y, but don't go left or right on x. Up on y, don't move left or right on x. So undefined is always going to be straight up and down. Now, for number 10, they're asking us to find the equation of the line L. Here's the L. Good. All they give us really are 2 points. Okay, so we have the point. I'm going to call it L1 is the point. I like going from left to right on the x-axis to find which one I choose as the first point. So L1 is -4, +2. L2 is going to be -1, -1. So if my L1 is -4, 2, that means my x sub 1 is going to be -4. My y sub 1 is going to be 2. Just don't get those mixed up. Over here, L2, my x sub 2 is going to be -1. My y sub 2 is going to be -1. Good? And we need to find a whole equation of this line. First, we're going to begin by finding the slope. Remember that equation? That equation is m equals y minus y. Then don't confuse the order. If you have y2 up here, make sure you have x2 minus x1. Good? Y2 we said was -1 minus y2, y1 is 2. Confusing. Here for x2 we have -1 minus, and then x1 is a -4. So make sure to include the minus and the negative sign. Good. -1 minus 2, we're adding negative numbers together, so we're going to get an even bigger negative number. But -1 minus -4, it's like a big plus, so that's actually going to be a +3. And you can put that into your calculator if you want to confirm. -3, so -1 minus -4 is +3. -3 divided by a +3 is going to be a -1. Because 3 divided by 3 is 1, but a negative divided by a negative is, or sorry, a negative divided by a positive is a negative. Good? So we found our slope is -1. Okay? Now, what do you do when you have the slope, but you don't have the y-intercept, but you do have some points on the line? We use the point slope form. What is the point slope formula? It is y minus y1 equals m times x minus x1. And we know what that y1 just means. We're going to plug in the y value of the point of the line. And that x1 means we're going to plug in the x value of a point on the line. It does not matter if you pick this point or you pick this point. Pick whichever point looks easier to work with mathematically. So this one has small numbers, 1, but they're both negative, whereas this one has bigger numbers, but one of them's positive. So whichever one looks easier to you, use that one. And we're going to substitute the x and the y in. So you're either going to use this pair or this pair, and you're going to substitute it in here. I'm going to do the -1s, okay? So y minus, it says that y2 was -1, equals, what's our slope? Our slope is -1. Times, and that's just x, minus, and then our x2 was also -1. And keep those parentheses because we need to distribute that -1 to the x and the x1. All right, so that all becomes, I'm going to rewrite it over here. This all becomes y minus a negative. When we subtract a negative, it becomes positive. Y plus 1 equals -1 times x. Same exact thing here. Minus a negative becomes a positive. Okay? Before you move, so what you want it to look like is y equals mx plus b, right? That's the equation we're looking for. I mean, you could put it in standard form, but I think the easiest form to leave it in would be this form. So we want to get y alone, but before you move that +1, you need to distribute the -1, okay? Do you see parentheses? That means we need to distribute. That's going to be multiplied by that and by this as the next step. So we have y plus 1 equals -1 times a positive x means 1x or negative x, and then that was a plus sign, right? Negative 1 times positive 1 is going to be negative 1. Good. We can rewrite this as y plus 1 equals negative x minus 1. Good. And remember, we want it to look like y equals mx plus b. So now we can subtract that 1 from both sides. I'm going to put it over here so that it's with its like terms. That cancels, and we have y equals negative x. Negative 1 minus 1 becomes negative 2. So the equation is y equals negative x minus 2. Good? All right. Here it says the equation of two lines are given. Determine if the lines are parallel, perpendicular, or neither. What are the rules for determining whether lines are parallel or perpendicular? What you want to look at is the slope of each line, okay? If they are parallel, same slope, okay? If they're perpendicular, that means we have the opposite inverse slope. We don't have enough room to write slope. Opposite means if it is positive, it becomes negative. Or if it is negative, it becomes positive. Okay? Opposite sign from positive to negative or negative to positive. And then inverse means whatever the number is, if the number is 2 over 1, it goes to 1 over 2. It gets flipped, right? So we go from positive to negative or negative to positive, 2 over 1 to 1 over 2, or 3/5 to 5/3. Okay? So if you do both of these, that means we have to change both the sign and the order of the fraction. Okay? So let's see if we can find the slope of the two lines. It's already in slope-intercept form, so we can see that the slope is 6 for the first line and negative 6 for the second line. Are 6 and negative 6 the same slope? Are 6 and negative 6 the same slope? They are not, so it's not going to be parallel. Are they the opposite inverse? Okay, so what I want you to do, it's confusing. This is a very confusing question. What I want you to do is I want you to take the slope of the first equation. The slope is a positive 6. Yeah? Turn it into a fraction. What is 6 as a fraction? If you want to make a number into a fraction, put it over 1. Don't add a minus sign behind it. Good. It stays the same, but it's in fraction form. Okay, so we need to take this fraction, we need to do the opposite. Right now it's positive, so if we want to make it opposite, it's going to be negative 6 over 1. Okay, you can put the negative here, you can put it down here, you can put it out in front. Okay, so the opposite slope is going to be negative 6 over 1. But then we need to do the inverse. The inverse means we go from 2 over 1 to 1 over 2. 1/6. Don't forget that negative though. The negative is still with us. So the perpendicular slope of 6 is negative 1 over 6. We took the 6, we moved it to the bottom of the fraction, and we changed the sign from a positive to a negative. Good? Is this negative 1 over 6? It is not. So it's neither perpendicular nor parallel. That's a really tricky question. It's generally easy to see if it's parallel. It's not easy to see if it's perpendicular. If it's not parallel, it's not perpendicular, we say neither parallel nor perpendicular. So find your slope, turn your slope into a fraction, change the sign of that fraction, and then flip the fraction. Okay? So find the slope, turn it into a fraction, change the sign of the fraction, flip the fraction. That's your inverse. That's your perpendicular slope. Here's one more example. Oh, we have two more examples. Okay. So our slopes are 3x plus, or sorry, our equations are 3x plus 6 and negative 1/3 x plus 8/3. We just care about the slope. So take your first equation, take the slope. The slope is m equals 3. For it to be parallel, they have to be the same. Okay? 3 and negative 1/3. Is that the same? No. So that is not parallel. Done. Is it perpendicular? What's the rule for perpendicular? Change the sign, flip the fraction. Change from negative to positive or positive to negative. Okay? Then flip the fraction from 1/2 to 2 over 1 or 6/5 to 5/6. Good. All right, so here's 3 turned into a fraction. 3 as a fraction is 3 over 1. What do we need to do? We need to change the sign. It was a positive 3, now it's going to be a negative 3. Flip the fraction. Keep that negative sign though, don't forget it. Negative 1 over 3. So the perpendicular slope of 3 is negative 1/3. Is that what we have here? It is. So we're going to say that this is perpendicular. Good? All right, last example. Here we have equations of two lines in slope-intercept form. So we know the slope is 8x, or sorry, I shouldn't say the x. The slope is 8 here, and the slope is 8 here. So the lines are parallel because that's the same slope. Two lines with the same slope. The only difference is the y-intercepts are different. Number 14 asks us to determine whether the graph illustrated represents a function. Okay, the wording on this is ridiculous, but is it a function? Yes, because a vertical line can be drawn to intersect the graph at more than one point. Well, that's not the definition of a function, is it? How do we decide if something's a function? Is it because a vertical line can be drawn to intersect the graph at more than one point, or cannot be drawn to intersect the line at more than one point? The rule is, it's called the vertical line test, right? So all we're going to do is we're going to take a vertical line, check several points on the graph, make sure that it only crosses the graph one time, okay? A vertical line cannot be drawn to intersect the graph at more than one point, okay? A vertical line cannot be drawn to intersect the graph at more than one point. Makes it a function. The wording is confusing because that and the only difference between A and D are the words yes and no. Okay? No, because a vertical line can be drawn to intersect the point graph at more than one point. So these two sentences are the only true sentences out of your multiple choice. Okay? We can just, I need a big black. Maybe red will do. This is not a true statement. This is not a true statement. Okay? If a vertical line cannot be drawn to intersect the graph at more than one point, that means it has to be yes, it is a function. If a vertical line can be drawn to intersect the graph at more than one point, then the answer should be no. Okay? So just eliminate those based on the wording alone. Okay? The rule is if a vertical line cannot be drawn to intersect the graph at more than one point, means a vertical line can be drawn and only intersects the graph at one point. Okay? So when I'm drawing these vertical lines, it can be drawn to intersect the graph at more than one point, or it cannot be drawn to intersect the graph at more than one point. It cannot, a vertical line cannot intersect the graph at one point. A vertical line can intersect the graph at more than one point. So do we say a vertical line can intersect the graph at more than one point? Or a vertical line cannot intersect the graph at more than one point? It cannot, right? Difficult wording. All right, give the domain and range of the function. The domain in interval notation, we see it. So domain is always your x-axis, right? How far does it go left? How far does it go right? If it has an arrow going even vaguely this direction, that means negative infinity. If it's going this way and it's an arrow, that means it continues forever, so that's positive infinity. So in interval notation, it would be from negative infinity to positive infinity. The range is our y-axis. Again, there's an arrow going down and there's an arrow going up. So we're going to say the range is from negative infinity to infinity. Good. List the value of y that corresponds to x equals 2. I've made a mess of this graph, but find 2 on your x-axis. You can even draw a line at x equals 2. All right, so find the value of y that corresponds to x equals 2. This line is x equals 2. What value of y corresponds to x equals 2, or what point does x equals 2 cross the graph? And that would be the point 2, 2, unless my vision's really bad. Let me look. I feel like that's right, right? Okay, so the point 2, 2 touches x equals 2 and the line. So we're going to say the value of y, it's not the point, it's just the value of y equals 2. When x equals 2, y equals 2. At least the values of x that correspond to y equals negative 4. So when y is equal to negative 4, right here, that's this whole line. This whole line of y equals negative 4. Where does it um touch the graph? It touches the graph right here at the point negative 2, negative 4. Right? Negative 2, -4. So what's the value of x? The value of x is just 2. Okay. Same thing for number 15. So what is the definition of a function? A function is a vertical line cannot intersect the graph at more than one point. Okay? A vertical line cannot intersect the graph at more than one point. A vertical line cannot be drawn to intersect the graph at more than one point. If a vertical line cannot be drawn to intersect the graph at more than one point, that's a function. So we're getting rid of this question, this answer. A vertical line can be drawn to intersect the graph at more than one point. If a vertical line can be drawn to intersect the graph at more than one point, that's not a function. So we're getting rid of this answer too. Okay, so find the only true answers. A vertical line intersects the graph at more than one point. A vertical line cannot intersect the graph at more than one point. Okay, just to simplify it for yourselves. For yourself. Good. And then just do the vertical line test. Imagine that you're drawing these vertical lines, and is there anywhere where the vertical line is touching the graph twice? And there is not, so we would say this is a function. Good? All right. Domain and range of the function. The domain are all of the x values. The x values, even though those arrows are going mostly up and barely left or right, they still are going left or right. So we are going to say it's from -infinity to infinity. Good. The range is the y, remember? So they are definitely going up, but there's no arrow going down. It actually begins at -4. It does look like it includes and touches -4, so we're going to put a bracket -4 to positive infinity as our range. Okay, so it goes from all real numbers on the x-axis and then from -4 to infinity on the y-axis. Same thing here that we did for question 14. The values of y that correspond to x equals 1, I would just like to draw a line for x equals 1. X equals 1 is every single point where x equals 1. Where would that cross this graph? It would cross it right here. And I'm going to say, so that's x equals -1, positive 1, sorry. X equals +1, y equals -1, 2, 3. That's the point 1, -3. So the y value that corresponds to x equals +1 is a -3. There's no second point because there's no other place that that line crosses the the graph of the function. Now, list the values of x that correspond to y equals 0. Y equals 0 is going to be this line. Every x value that is on the line of the x-intercept, because y equals 0 there. Now you'll see that this does cross 2 times, and that's okay because that's not a horizontal, that's not a vertical line, that's a horizontal line. So that doesn't mean it's not a function, but it does mean that you will have more than one answer. Okay, so you want to see where they cross. They cross right here and right here. So those 2 points are -2, 0 and +2, 0. When y equals 0, x could equal -2 or +2. Good? Okay. 16. Does this graph represent a function? A vertical line can be drawn to intersect the graph at more than one point. A vertical line cannot be drawn to intersect the graph at more than one point. Vertical line can be drawn to intersect the graph at more than one point. Okay, the definition of a function is a vertical line cannot be drawn to intersect the graph at more than one point. If it's not a function, it's because you drew a vertical line and it intersected the graph at more than one point. Now do your vertical line test, and we see that we do cross at more than one point, so we're going to say, no, this is not a function. It doesn't mean you shouldn't continue the question, though, okay? We can still find the domain and the range and the y values and x values, okay? The domain is x. So where does x start and where does x begin? There are no arrows, so this is going to be a more precise problem. I just box my function, okay? Where did my function start? It started at -6. It touched -6. It ended at +6. It touched +6. So I'm going to say my domain is from -6 to 6. And don't overthink about whether to put this bracket or a parentheses. If it looks like it's touching, okay? Y, the range. So again, I'm just boxing in my function. And I'm trying to determine what those numbers are. So that's y equals oh, 0, right? That's what I was going to say. Y equals 0. Y equals, oh, I don't believe that at all now, because look at that. I'm confusing myself. This is the x-axis. So it's not y equals 0, it's y equals -1. Y equals -1. And here is y equals 1. Right? So it starts at -1 and it goes until 1. From -1 to 1 on the y-axis. And they're asking for it in interval notation, that's why we're writing it like that. Okay, now, now that I've graffitied all over this, I just have to keep looking at it. List the values of y that correspond to x equals 6. X equals 6. Well, yeah, we already drew that. That's the purple line. X equals 6 is this line. When x equals 6, y equals, so when I go out to here, how far up or down did I go from the origin to find the relation? It's just at y equals 0, right? When x equals 6, y equals 0, or the point 6, 0. And then second part, list the values of x that correspond to y equals 0. So again, that's just that line. When y equals 0, x equals, and there's two different answers. When y equals 0, x is -6 and +6. And I just got that from looking at this graph, even though it's really hard to look at because of how much I've drawn all over it. But when y equals 0, that's that whole line. Where does that line cross the relation? At -6 and 6. All right. 17, we're moving on to away from graphs. This is asking us to find f of negative x when f of x is 3x squared minus 5x minus 2. Now, f of whatever then is inside these parentheses is what you substitute in for x, and then you either solve it to get a number or you just simplify it into an equation, which is what we're going to do this time because it looks like none of these are just number answers, right? So find, and then you just substitute. So f of x is 3x squared minus 5x minus 2. Take that x and put in negative x for it. So f of negative x is 3 instead of x, I'm putting in negative x squared minus 5, again, substituting in negative x, minus 2. And then you just simplify that. So just simplify it. Be very careful when simplifying it. F of negative x equals 3 times negative x squared. So a negative x squared, you can't really put that into a calculator, but you can think about how it would simplify. So if it was negative 3 squared and 3 squared give you the same, right? So whatever x is, negative x times a negative x is going to be a positive. So we're going to call that 3x squared minus negative 5 times negative x is actually going to be a negative times a negative becomes a positive 5x minus 2. I'm going to go back to this real quick. I don't think I explained it as well as I could. So 3, and then we have negative x squared, which just means negative x times negative x. Right? And then a negative times a negative becomes a positive, and x times an x is just x squared, so it's just 3x squared plus 5x minus 2. Is that one of our options? Positive 3x plus 5x minus 2. So I would pick B. Good? Okay. For 18, we have let f of x equals x squared plus 16 and g of x equals negative 5x plus 20. Find f of negative 6 minus g of negative 6. First thing we're going to do is substitute the negative 6 in for the x. So in this case, this x becomes negative 6. Good. What's negative 6 squared? 36. So f of negative 6 is 36 plus 16, which is 52. All right, next step is substitute negative 6 in for the x of g of x. So g of negative 6 is negative 5 times negative 6 plus 20. Simplifying that is negative 5 times negative 6 is 30. Positive 30 plus 20. So g of negative 6 is 50. Good. So now we know what f of negative 6 is. F of negative 6 is 52. Keep that same minus sign. Minus g of negative 6 is 50. That one's positive. That one's positive, just making sure that I don't make a mistake like that, right? And then we say equals 52 minus 50 equals 2. Good. 19, f of x equals x squared plus 7 and g of x equals negative 4x plus 5. Find f of 3 times g of 3. So same exact thing. F of 3 means I'm taking that 3 and putting it in for x. F of 3 equals 3x, sorry, 3 squared minus 7. 3 squared is 9 plus, ooh, it's not plus, it's a minus. 9 minus 7. 9 minus 7 is 2. Good. We're here. G of x, I'm going to put in a 3 here. G of 3 is negative 4 times positive 3 plus 5. Negative 4 times positive 3 is a negative 12 plus 5, negative 7. Good? Okay, this is different. F of 3 times G of 3. That dot means we're multiplying them. So that's 2 times negative 7, which is negative 14. For the pair of functions f of x equals x plus 5 and g of x equals 5x minus 3, find the following. F of g of x, f of g of 2, and g of f of x, and g of f of 2. Okay, f of g of x means that you want to take that second function and put it in for x of the first function, okay? So take your g of x and put it in for the x of the f of x. So instead of this x, we're going to put in g of x. G of x plus 5. And then what is g of x? G of x is 5x minus 3. We don't really need those parentheses in this case, so it'll just be 5x minus 3 plus 5, which is 5x plus 2. God, I'm bad at writing. 5x plus 2. Good. Here we're kind of doing, no, we're not doing the opposite. F of g of 2. We've already found f of g of x, and so you can just put in a 2 for it. So it would be 5 times 2 plus 2, which would be 10 plus 2, which would be 12. So you can do it that way. Or you can put the 2 into the g. So the g was 5x minus 3. So, oh, sorry. Okay, so I should explain this better. Or you can find the g of 2, which would be 5 times 2 minus 3 equals 10 minus 3 equals 7. And then put that in for your f. So f of g of 2 equals 7. So it would be f of 7 equals 7 plus 5, because I put that in for my x. equals 12. Explained that terribly, I'm pretty sure, but so you can either use that formula you already found, or you can put that first number that they gave you in for G, and then when you get that answer, put that in for into F. C, they're asking us for kind of the opposite, G of F of X. So we're going to take F of X and put it into G. So we have 5 times F of X minus 3. And then what is F of X? F of X is X plus 5. Oh, sorry about that. So now I'll distribute that. 5 times X is 5X. 5 times 5 is 25. Minus 3. 25 minus 3 is 22, so we have 5X plus 22. And here we have 12. And for G of F of 2, obviously you can just put the 2 in here. 5 times 2 plus 22 is 10, plus 22, which is 32. Or, I'll try to do a much better job of explaining this. G of F of 2. All right, we have F of X equals X plus 5, and we have G of X equals 5X minus 3. They want to know what G of F of 2. Okay, first thing I'm going to do is F of 2 equals 2 plus 5, right? So I just put 2 in for X. F of 2 is 2x plus, or sorry, it's 2 plus 5, which is 7. So F of 2 is 7. So G of F of 2 is G of 7. Good. So I'm going to take that 7, put it right here. F of 2 means I took X and I replaced it with a 2, solved it for 7. Now that's 7. Replace that whole F of 2, right? So F of 2 means I replaced 2 with X to get 7. And then that whole F of 2 became G of 7. That whole F of 2 became 7. So G of F of 2 is G of 7. Now I'm going to replace the 7, the X with the 7. So G of 7 equals 5 times 7 minus 3. 5 times 7 is 35 minus 3, which is 32. All right, 21. List the intervals on which f is increasing. Now, for this, I just go left to right. I know that left to right, this is decreasing, right? I'll say this is unchanged. And this is increasing. They're only asking where it's increasing. Now, I know you can't really do this because it's on a computer, but just go from left to right. Think about from here to here, they've marked all the points where something might change, okay? From this point to this point, is it going up or down? It's going down. You don't even need to really highlight it if it's going down. Which is it increasing? From here to here, it's increasing. From here to here, it's increasing. Then it goes, starts decreasing again. And then it goes up. And then it goes down. And then it goes up. So I'm just reading it like you read a book. Left to right, is it going down or is it going up? If I'm reading it from left to right, or if I'm like, you can even imagine you are hiking, right? So I'm like hiking along, and then I'm hiking down, then I'm hiking up, then I'm hiking down, then I'm hiking up, then I'm hiking down, then I'm hiking up. They want to know where you've gone hiking up, okay? So I'm going to say it's from here to here I was hiking up. And then again from here to here I was hiking up. And then from here to here I was hiking up. Whoosh. Okay. So from -6 until, what would we call that? 0? I was hiking up. From 0 to 2, I was not hiking up. But from 2 to 4, from 2 to 4, I was hiking up. And then I went down again. And then from 6, 7, from 7 to 9, I was hiking up. Okay? So that's how you tell if it's increasing. Hmm? Did I go down? Did I go up? Did I stay flat? Constant. Sorry, that's the word. Decreasing, constant, or increasing. 22, use the graph of the function to answer the questions. List the values of x at which f has a local minimum. Okay, a local minimum is a valley. It has to be going up, has to be a low point, and it has to be going up on both sides. Okay? That. That. Okay? That point is -9, -9. This point is 3, -9. That is not a local minimum because it doesn't come back up. It doesn't come back up. It has to be a valley that comes back up on both sides. Okay? So we found the 2 points that are local minimums. They don't want the points. They want the values of x. So when you have a point, what is your value of x at that point? My values of x are +3 and -9. Okay? What are these local minima if they exist? Now, what is the local minima? What is this low point? And if we're talking about high or low, we're talking about y values, right? What is the local minima? How low does it go? It goes to -9. You don't need to write it twice, okay? Let me make sure that's true. That's not true. You need to write it twice. Good. So the local minima of this one is -9. The local minima of this one is -9. And they're just asking for the low point or the y value. Okay. 23. Use the graph to find the numbers at which f has a local maximum and the number that f has a local minimum. Okay. Local maximum has to go like this. As we discussed, local minimum has to go like this. Okay. So we're not going to count that guy because he doesn't come back down. I'm not going to count that guy because he doesn't come back down. But local minima are this guy's a local minima and this guy's a local minima. Even if his shape is more like that, it still does go down, come back up. Okay. I guess I started with the local minimum, so I'm going to come down to part B. The value of x at which f has a local minimum, the value of x, remember x, y, x, y. The values of x are x equals -1 and 2. Good? The local minima is 0. And as I just learned, y equals 0, write it twice. Both times it was 0. Good? Okay, now let's go back up to local maxima. Local maxima, it's going like that. What point is that? That would be the point 0, 1. The value of x at which f has a local maximum, what is the x value of that? The x value of that is 0. The local maxima is, how high up did it go? It went up to 1. All right. Is this function even, odd, or neither even nor odd? Remember the rule. An even function is unchanged when reflected about the y-axis. Okay? Here's our y-axis. If I folded it right here, if I put, not, let's not fold it, let's put a mirror. If I put a mirror right here, that means that the mirror would show a line like that, right? Okay, so this side of the graph needs to mirror that side of the graph. It needs to go like that. Shoot, did I mess up my focus? Right? So a matching graph, an even function, would need to go like this across the y-axis because a function is even when you can reflect it across the y-axis. Okay? Is that even? It is not. All right. A function is odd if you can rotate it 180 degrees. So think about that. 360, right? If you're doing a 360, you're coming all the way back to where you were. If you're doing a 180, you're just flipping over, right? So if I have this graph, and this is what I would recommend you do. So you've got, it starts at -4 and it just goes up like this, right? So I've got this graph. If I take it and I rotate it 180 degrees, so I drew the first graph I had. I rotated it 180 degrees. Is it the same? It is not. So it cannot be odd. It cannot be even because it does not mirror itself across the y-axis. It cannot be odd because if I draw a picture of it and then turn that picture 180 degrees, he was standing like this, he 180'd, now he's standing like this, he's not the same. So it's neither. All right, same thing. I'm holding up to determine whether it's even. If it's even, it needs to match both sides like that, for example, right? If I hold up a mirror, what does it need to do on the other side? It needs to come up on the other side. So that would be even. It's not even. It's, is it odd? Done with that one. Draw another XY axis. Draw my graph. Okay, that's my graph. He's standing like that. Flip him 180 degrees. Does he look the same? He does. So that is an odd function. Good. 26. The graph of the function is given. Decide whether it's even, odd, or neither. For it to be even, we need it to mirror itself. So if I hold up a line that I'm calling a mirror to the y-axis, if it goes like this over here, it needs to continue and go like this over here. Does it? It does. So it is even. Good? So that's how we just determine whether a function is even, odd, or neither if we only have the graph and we do not have the equation. Now we need to determine algebraically whether the function is even, odd, or neither. So we do not have the graph, we only have the problem. Okay, so the rules are, if it is even, then f of negative x will be exactly the same as f of x. If it's odd, and I make that x a negative, it will make the whole function a negative. Okay? So what we want to do is we have f of x equals 7x to the fourth plus 6x squared. We're going to change from f of x to f of negative x, which just means all of those x's become negative x. F of negative x equals 7 instead of x to the fourth, it's negative x to the fourth plus 6 negative x squared. Good? Now let's simplify that. Negative x times negative x times negative x times negative x plus 6 times negative x times negative x. We'll simplify that. Negative times a negative times a negative times a negative is a positive. Negative times a negative is a positive. So it becomes 7 positive x to the fourth plus 6. Negative times a negative is positive x squared. So I put in a negative x for my x value. And what did I end up with? I ended up with the same equation I started with. Right? So f of x is 7x to the fourth plus 6x squared. And we just proved that f of negative x is also equal to negative 7x, or sorry, 7x squared to the fourth plus 6x squared. Good? So that means it is even. We put in a negative x and we came out with the same equation. So that is an even function. I know it's easy to become confused. All right, 28, determine algebraically whether the function is even, odd, or neither. Remember, even, we make that x a negative, but we come out with the same function. If it's odd, we put in negative x, and it makes the whole thing negative. Okay, so for this one, we've got g of x equals 7x squared minus 4. So g of negative x is going to be 7 times negative x squared minus 4. 7 negative x times itself. Two negatives make a positive, right? So that's 7. Negative times a negative is a positive. X squared minus 4. So g of negative x gives us the same um, equation as g of x. So we're going to say that that is an even function. If f of negative x is equal to f of x, it's even. If g of negative x is equal to g of x, it's even. 29. This one's a little bit scary because it's a fraction, but don't be scared. So we're going to do the same rules. We're just going to make that x into a negative. And see if we get the same answer, or if it turns the whole thing negative, or neither. Okay, so f of negative x is equal to 1 over negative x to the power of 4. Good? Negative times a negative is a positive. Negative times a negative is a positive, so it's x to the 4th. So f of negative x is the same as f of x, so we're going to say it's even. All right, number 30. If f of x is defined as follows, find f of negative 1, f of 0, and f of 2. So this is, the math isn't difficult, but just understanding what they're asking is the most difficult part, okay? So if x is less than 0, okay? If x is less than 0, f of x equals x squared. If x is equal to 0, f of x is equal to 0. And if if x is greater than 0, f of x is equal to 2x plus 3. Okay, so now I want you to go through these examples. Remember, f of x, that means these are the x values. Okay, negative 1. Negative 1 is less than 0. Good. Keep going. 0 is equal to 0. And 2, our last one, is greater than 0. So what they're asking you to do is to use this equation for this one, use this for this one, and use this equation for this one. Okay? So it's just a matter of knowing what to use when. So because it's less than 0, we're going to say f of x is equal to x squared. So f of negative 1 is equal to negative 1 squared, which is 1. Negative 1 squared is negative 1 times negative 1, which is 1. f of negative 1 is 1. All right, for the next one, f of 0 means f of x equals 0. There's not even a place to put in 0, to put in an x. You just say it's 0. And for that last one, we have f of 2. So that means x is greater than 0. F of x equals 2x plus 3. F of x equals 2x plus 3. So f of 2 is going to equal 2 times 2 plus 3, which is 4 plus 3, which is 7. Good. All right, so that's the model we're using. Let's try it again. Okay, this is a little bit more complicated, but again, I just want you to understand this part, the part after the if, okay? And then for each of the 4 questions they ask you about, decide whether it goes here or here, okay? Are we talking about a number between and including -5 and 3? Are we talking about a number that is between 3 and 4? Okay? So again, I'll just highlight them for simplicity. Between -5 and 3. Is 0 between -5 and 3? It is, right? Here's -5. Here's 3, 2, 1, 0. Uh-oh. 1, 2, 3, 4, -5. Yeah. Is 1 between -5 and +3? It is. All right, here's the puzzle because I see a 3 here and I see a 3 here. This equal sign means and equal to 3, right? So this 3 is still going to be in the 5x minus 4 category. Only the 4, only for the 4 are we going to use this second equation, okay? So all that means is now for f of 0, we're going to say 5 times 0 minus 4. Okay, f of x equals 5x minus 4. So f of 0 equals 5 times 0 minus 4, which equals 5 times 0 is 0, -4. Good. Next one, we've got that same equation, f of x equals 5x minus 4. So f of 1 equals 5 times 1 minus 4 equals 5 minus 4, which is 1. F of 3, still using the same equation, f of x equals 5x minus 3. So f of 3 equals 5 times 3 minus 4, which is 15 minus 4, which is 11. And for f of 4, we're using the other equation. F of x equals x cubed minus 3. So f of 4 is equal to 4 to the power of 3 minus 3. Now you can put that into your calculator, or you can just say 4. What's 4 times 4 times 4? It's 64, right? 4 3 times. 64 minus 3, which is 61. 32 says the function f is defined as follows. F of x equals negative 2x plus 3 if x is less than 1, and f of x equals 3x minus 2 if x is greater than or equal to 1. Okay? What would the domain of the function be? And locate any intercepts. Okay, for this one, you can graph it. And if I were to graph it by hand, so we have the lines f of x equals negative 2x plus 3. So that means it crosses. Remember that we can look at this as y equals mx plus b. So it's going to, where b is the y-intercept and m is the slope. So it's going to cross at positive 3, and then the slope is negative 2, which is negative 2 over 1, right? So that means I go down 2 over 1, down 2 over 1, down 2 over 1. You can also do the opposite, right? Because you see that it's a line, so you can go positive y, negative x, positive y, negative x. So I'm going to draw this line like this on my graph. So that is a line on the graph when x is less than 1. So let's mark where x equals 1. Tried. All right, where x is less than 1, this is going to be the graph of the function. So I don't need to dash this line. This is the real line of the function. Okay, now I'm going to take the other equation, and it was f of x equals 3x minus 2. And same thing, we have a slope and we have a y-intercept. Our y-intercept is negative 2. And our slope is 3. So that's up 3 over 1, up 3 over 1. So now, this is the graph after I'm terrible. After x equals 1. Can I make that any better? All right, so we got that one. And that one. And these obviously, they go forever in that direction. And this one goes forever in this direction. And this one includes the 1. Okay, the 1 is included with this line. So what are they asking us about this graph that we've created? Find the domain of the function. Remember, domain is the x value. So here we're pointing to the left or to the negative direction with an arrow, and we're pointing to the positive direction with an arrow. So it's from negative infinity to infinity. And locate any intercepts. You see any intercepts? I see the intercept of 0, 3. It will not cross the x-intercept. It crossed the y-intercept at 0, 3. It will not cross the x-intercept because this one was going down, but this one was going up. And so when they changed right at y equals 1, so it will never get down to y equals 0. Good? All right. And choose the correct graph. So does it look like A, B, C, or D? Well, we graphed it. We see that the lowest point is at 1, 1. So we can put that on our graph. 1, 1. Oh, it's like 10, 10. God, that's annoying. 1, 1, 1, 1, 1, 1. Good. So which ones can we eliminate? We know it's not this one, right? Do they meet? Yes, right? Because this is where it changes, but this is also where this one and this one meet. So I'm going to say it's B. Good. Based on the graph, find the range. Remember, the domain is the x values. What is the range? It's either the range does not have any isolated values, and then you are going to write it in interval notation as we've written all of the other ranges thus far, or the range has one or more isolated values. So that would be described as the union of the intervals. So that would be if there were maybe two circles, then there would be two different ranges. Or C, the range consists exclusively of one or more isolated values. And in our case, we chose this one. So this range, it begins at 1, right? It begins at and includes 1, and then it goes up forever. So we're going to say it's from 1 to infinity. It does not have any isolated values, and it can be described by bracket 1 to infinity. Good. All right, and before we move on to 33, I don't think I explained very well what an isolated value and a set is, okay? Interval is this, right? So for 32, for this graph, the interval of the range is from 1 to infinity. So we just call it 1 to infinity. If for B to be true, we would have this graph plus maybe that point is also on the graph. Okay. So then we would say it can be described as the union of the interval from 1. Oh, sorry, that doesn't work. I'm going to put it down here. That's not real. This point right here. The interval from 1 to infinity, because that's a continuous, right? That's a continuous line. And all a line is just every single point so close together that it's touching, right? A line is just a bunch of points, okay? So the interval from 1 to infinity and the set, I'm just going to say the set, -10, because the set is just one isolated value, okay? Or the range consists exclusively or isolated values. That means there's no lines on the graph. There's maybe just the point -4 and the point -1. Yeah? Then you would say just little points appearing on the graph is what that means. Okay? So moving on to 33, we'll just do it one more time. And again, I'm going to just graph it by hand because this is what I'm most comfortable doing. So we have 3 different little graphs on here. We're going between -2, 1, between -2 and 1, right at 1, and then at greater than 1. So I'm just going to draw those lines now. I need like a real ruler. Let's try to be better. Again, it was -2. Can't be better. -2. +1. So those are where the graph is going to be changing. It's going to change from x plus 3. So let's graph that. X plus 3 means that sorry, I should not rush through this. F of x equals x plus 3 means our slope is 1, right? Because our slope is always right next to our x, which you can call 1/1. And then our y-intercept is 3. So I'm going to start at 3, and then I'm going to go up 1/1, up 1/1, up 1/1, okay? Start at 3, and then up 1/1 would be right here. You can also move backwards, so negative, negative y, negative x, negative y, negative x, negative y, negative x, positive y, positive x, positive y, positive x. So that's my line. That line is true if it's between -2 and up to 1. So from -2 to 1, we got this guy. However, it does not include 1. So to not include, remember, means you have a big open circle. So that circle is open. That is not the value of 1 because it said less than 1. Okay? When x is equal to 1, when x is equal to 1, so it just means for this line right here, when x is equal to 1, f of x is just 9. We're going to put that point right there. Okay? So far we have the graph like this. Not right there, does not exist right there. It starts, you're hiking, hiking, hiking. You fly up to here. Okay? You never touch 1, 4. You go 0, 3, 0.9, really close to 4, and then you jump up to 4. So you're never touching this one. And then we have the line -x plus 2. Let's talk about what that would look like. -x plus 2 means your slope is -1, which is just -1/1, and that your y-intercept is 2. Good? So go over to 2. That's your y-intercept, and then down 1/1, down 1/1, down 1/1. Okay, and when is that true? That is true if x is greater than 1. So when x is greater than 1, we're doing this. And again, we're making it clear that it does not count the actual spot, okay? So from here, you go up, you leap up here, and as soon as we get past one, you fall down to here and go down, and it will go on forever because it just says greater than one, right? This does not say forever. It says between -2 and 1. So this one does end. This side ends, this side does not end. We jump up to 9 at one point, okay? So we've graphed that. Let's jump down to C and decide which one this is. Well, it's got a big old point up here, right? So it's not this one, and it's not this one. Were they disconnected or were they connected? They were disconnected. So we're going to say it's C. Now that'll make it a little bit easier to answer all these questions because I know my graph is way too big, so I couldn't fit everything in the view. What is the domain of this function? The domain, remember, is the x values. So it starts at -2, right? So from and including -2 until it doesn't include 1, but wait, it does include 1 up here, so we're okay. And then after 1, it goes on forever. So we're saying from -2, continues, even though it does a big jump, it is continuing, jumps back down, continues forever. So from -2 to positive infinity. Good. So the domain is -2 to infinity. And what are any intercepts? We found both of the intercepts. There's one intercept at 2, 0, and another intercept at 0, 3. Sorry, 2, 0, 0, 3. Good. It's that graph. Based on the graph, find the range. So this was the hard part, the confusing part, I think, the most confusing part. And if we look at this range, the range has at least one isolated value. At least one isolated value is that 9, okay? So that isolated value is the number 9, and we're going to call it a set, okay? And there's also an interval. So it jumps up here, and then not counting that one, what is the range? The range is from -infinity up to 4. After 4, there are no more lines. There's just a dot. So that dot is covered by the set 9. And then we just describe this as -infinity, because it's going forever, -infinity to 4. Good? I did that wrong. Since that 4 is an open circle. Sorry, we can look at this. Since that 4 is an open circle, it's going to be -infinity to 4 with a parentheses instead of a bracket. Okay. 34. Choose the function that matches the given graph. So that to me looks like the graph of y equals -x squared, right? Because if we think about y equals x squared, it looks like this, right? The absolute value looks more like that. And And those are our only two options. It's either x squared or the absolute value of x, right? Absolute value of x looks like this, right? So it's not those. It's y equals x squared. So what do we see in our multiple choice options if you're still not sure which one of these it is, right? Y equals x squared opens up. This one opens down. How do you get from opening up to opening down? Negative x squared is going to give you that same graph, but opening down. So I'm going to eliminate any that don't include the x being negative. Good. And then what's the next difference? It opened down, and instead of starting at 0, 0, it starts at positive 6. So what would have caused it to move up 6? Would it be to multiply the x squared by negative 6, to add 6, or to put it in the parentheses with the x? Or sorry, to add 6 to the x before you even square it. What do you think? So if we multiply it by 6, that's just going to make it 6 times narrower, right? That's going to be a tiny little graph like that. So it's not that one. If we add 6, that will raise it up by 6, right? So that one looks correct. And this last one, negative x plus 6 squared. So what you're doing is you're then this one, because the 6 is being added inside of the function x squared, what you're doing is you're moving it left or right, right? In this case, you'd be moving it left because it's adding 6, so you're doing the opposite. You're moving it slightly to the left. So that would be left or right movement, whereas outside of the parentheses will be up or down. Up or down movement. Good? All right. So that's why it is negative x squared plus 6. You switched it from top to bottom, and then you moved it up 6 places. 35. Here we have kind of the same thing where it's either x squared or the absolute value of x. This looks, because of the sharpness of it, right? It looks more like absolute value. So I'm going to get rid of anything that was an absolute value. I'm going to think about what the absolute value actually looks like. Y equals the absolute value of x. What does that graph look like? That graph just looks like a V starting in the middle, right? This V is turned around, right? So that probably means it was negative, just like the last one. If you make it negative, you flip it across the x-axis. So that means we can eliminate positive ones. So now we just need to decide, kind of like the same as the other one. Are we multiplying it by 4? Are we adding 4 inside the x value? Or are we adding 4 to the x value, or are we adding 4 to the y value or to the entire equation, right? And remember, just like the last one, where'd it go? In the last one, we see that adding to the y value moves it along the y-axis, okay? Here, if we want to move it along the x-axis, we need to add it to the x value. How far did we move it? We moved it -4, right? And remember, when we're moving this way, it's the opposite. It's the opposite direction. So this is actually +4, but it needs to be inside the absolute value bars. So that's going to be x +4. To get it to move over here, and then -x to get it down here. So the -x gets it down here, and then the +4 moves it over after you've got it down to the other side. All right, let's do two more. 36. Here we've got another absolute value. It's negative again because it's facing down. If it was positive, it would be a V going up. So it's either, here we said inside the absolute value bars, or adding to the x moves it along left or right, right? Are we moving it left or right? No. So we can get rid of this one because we are not moving it left or right. That one was to go along the x-axis, right? These were positive. That's why we didn't need them. These were not absolute values. That's why we didn't need them. So, oh yeah, there's a more positive idea. So is it -x +9 or -9 times negative absolute value of x +9 or -9 times the absolute value of x? Remember, multiplying it just makes it smaller, right? So we're not making it smaller. We're adding 9 to the y to move it up. So we moved it up. We have that absolute value graph going right through the origin. That's what we started with. Y equals the absolute value of x. We made it negative absolute value of x, so that now it goes like this. Good. And then we added 9 to make it go. Added 9 outside of the absolute value bars to move it up 9 on the y-axis. Good? Okay. Another one. Is this an x squared or an absolute value? It is an x squared, so we'll get rid of the absolute values. It's been flipped over, so it's been turned negative, right? And then what else happened? So we went from x squared to -x squared. And then we moved 4 along the x-axis. So moving 4 in the negative direction on the x-axis means we add 4 to x. Good? Okay. 38, we're kind of doing the opposite of what we were doing up there with the graphs. We're going to have the graph of y equals -x. You've got y equals square root of x I'm really bad at this one. 0, 0, 1, 1, right? 4, 2. Okay, you got this. All right, so that's the original. Y equals the square root of x, right? Now we're going to shift down 4 units. So instead of starting at 0, 0, we're going to start at 1, 2, 3, 4. -4, we're going to shift this one down. Right? How does shifting down 4 units, how do we represent that in an equation? Do we subtract 4? We're not multiplying, right? Are we subtracting 4 from an x or from the y? Remember, if we subtract it from the y or from the whole equation, that means we move up or down on the y, right? So outside of the x, we're going to say square root of x minus 4, because y, it follows, right? If you're going down, you subtract 4. Good? And then reflect about the x-axis. Reflect about the x-axis. So we're folding it in half. So instead of like this, it's going to be like this, like this, like this, like this, right? Bad start. And what did we learn from our previous examples? It was up like this. If I put a negative in front of the whole thing, it's reflected across. It goes from up here to down here, right? So we're going to make the whole thing negative to reflect across the x-axis. So that's y equals negative square root of x minus 4, right? And then the last bit of instructions was reflect about the y-axis. How do you get it to reflect across the y-axis? You just turn the x itself negative. If you turn the x itself negative, it flips over to here. Right, this was a hard one. But my final answer is y equals negative. What's that last change we made to flip it over here? We made the x negative minus 4. Good? So y equals negative square root, negative x minus 4, close the parentheses. So that's why it's important to do it in their order so that you know where to put the parentheses and how to do it just one step at a time. All right. In this case, you think we can do it without graphing? Okay. Find the function that is finally graphed after the following transformations are applied to the graph of y equals the square root of x in the order listed. Reflected about the x-axis. Remember, that is just from here to here. How do we do that? We make the whole thing negative. So that becomes y equals negative square root x. Shift it down 6 units. Y equals negative square root of x. Down 6 units means we subtract 6. And then left 5 units, right? Left and right is going to be our x. And it's the opposite, right? Left is a negative, so we want to add 5. Where do we add it? We add it underneath the radical. So it's y equals negative square root of x plus 5 minus 6. Those parentheses should not be there because of the order we went in. I apologize. Okay, that's why the order is important. So we shifted it down, or sorry, we reflected it and then we shifted it down. So the negative is not going to apply to the negative 6 because we've already shifted it down. Or sorry, we've already reflected it. So shifting it down is not going to be impacted by reflecting it. So there should not be a parentheses. I apologize. Whereas in this case, there should be a parentheses because we shift it down and then we reflect it. So after we shift it, we reflect it. If we reflect it, we don't need to carry that reflection to each next step. Okay? So if it was the last step, there would be parentheses because it would need to include everything. But because it was not the last step, it should have only been applied right there and not have been applied to the negative 6. Okay. Sorry for the confusion on an already very confusing problem. Graph the following function using the techniques of shifting, compressing, stretching, or reflecting. Start with the graph of the basic function and identify at least 3 key points. Find the domain and range of the function. So we're going to pick the correct graph. So we have the square root of x is usually right here, right? Now we're going to add 5 inside the parentheses. Add 5 only to the x. When we add to x, we move left on the x axis, right? If that was outside of the radical, we would go up 5, but it's not. All we did was we added to x, and remember x, we do the opposite. So we're subtracting 5 from where it starts. So it's D. The domain, remember, is all of the x values. So the domain is from and including -5 to infinity. And the range is from 0 to infinity. Good? Starts at 0, goes on forever. I know it's not going very high, but it will go on forever, so you have to say infinity. 41 will not. Okay. I don't think I'm going to do this one. I don't think this would be on the exam. That's a little bit too hard. All right, guys, that is the exam 2 study guide. Thank you so much. Email me if you have any questions.